Hi. So in this video, we're going to show you how to make a very simple chatbot web application, and then you are going to embed that into Qualtrics. In this web application, the users can type messages in the your message chat box, send it. And while waiting for the response, the send message button is actually grayed out so that we prevent people from typing multiple messages before the replies. And then once the reply is received, you will see the message of the participant and also the AI's response posted in the conversation history that gives you the conversation feel. Um, so the web application not only does this kind of chat function itself, but it also posts messages behind the scene to the Qualtrics so that there is a communication between the web application that embeds into the Qualtrics, which we will show in the next video. The Qualtrics can capture these behind the scene messages and save that information into the embedded variables in Qualtrics so that the two set of data from the web application and from the Qualtrics can be linked. And also at the same time, all of these conversations are being saved into a secure Google Sheet document so that we have all the conversation data. So in this video, I'm going to go through the code and show you how this web application is made. So here we're using Shiny and RStudio. However, there are many other languages that allow you to do this. I'm using RStudio only because I'm a R user and I can debug it better. However, it's very easy to take our code, which is posted on the e-companion of the paper, and just feed it to an LLM and let it translate to a language that you're more familiar with and use that instead. The overall structure of the Shiny app code is basically we have a bunch of libraries that we load. We have some housekeeping items. These are the things that you will have to modify essentially when you set up your own web application. And then we have some functions that we define to simplify the code. And then the two major parts of a Shiny web application is that there is the code that defines the user interface. So these will determine how the web application looked. It essentially defines what you have just seen. But also the server logic is the other part that essentially handles the behind the scenes. So if the participant input a message into the chat box and hit the button send, what happens next, right? So this takes care of what happens after that is that we take the message and we send it to the OpenAI API and we get a response and then we display the response by updating the conversation log. But also at the same time, at the launch of the app, essentially, we send some sort of launch information and also to the Google Sheets and we store all the conversation in real time to the Google Sheet. So we have the conversation data. This is also handled by the server logic. And also the server logic would handle the message sending, the communication to the Qualtrics page. Okay, so now I'm going to just go over the code sort of in chunks. So first of all, the two Shiny libraries, these are for the Shiny web application. The HTTR is required to communicate with the OpenAI API. The JSON Lite is for essentially the communication with the Qualtrics. The Google Sheet 4 allows us to store the data in Google Sheet. And the gargle is the authentication method for the Google Sheet because the Google Sheet is password protected. The few things that we need to set up. First of all, we need to have this JSON file that is the account credentials for the Google Sheet. Again, because we do want a secured place to store our data. So you need the authentication, but we don't want to have to input it by hand. So this is the way to essentially accomplish that automatically. So we will talk about how to set up the service account and obtain the service account key in video 4. Um, so here, this is just stored locally with the code itself. Here we have the OpenAI API key, but you can use other API services. Essentially, you will get this key from a service provider like OpenAI, like Google. So next is the system prompt. Here we're setting up the system prompt in a static way. We want the prospect theory type of behavior for this particular chatbot. That means prefer certainty in gains and gamble and losses. However, you can give your chatbot its own identity, its own preferences, and it can even be set up dynamically. You would just need to listen for information from the Qualtrics side, for example. But right now we're setting it statically. The next is to set essentially the Google Sheet URL and also the exact sheet that you want to store the information. The next is the set of functions that we define. Okay, this is the ID that we generate for each session. We also have the launch data. Again, this is more for robustness because we do not force the participant to interact with the web application, but we do sort of want to know whether the web application is working fine for them. They're able to see it. So here we also add a record of app launch. Basically, what we're saying is the app has successfully launched. The next function is the function that actually handles the message sending and response. Right? So here we set up the API key. This is the URL for OpenAI chat completion. Um, the system prompt is already set previously. We put it in a list and pass it with the rest of the prompts to the API. Here we set the model. And finally, the function essentially returns the response message from the API call. And lastly, we have another function that handles the message saving or the conversation saving to the Google document. We store the session ID and the timestamp for each of the conversations into the specified Google document at the exact Google Sheet. So now the UI is very simple. We have a message input area and we have a conversation log. And we have a spinner essentially that loads when the conversation is being sent and waiting for the reply. So next up is the server logic. So for when the session launches, we generate a random ID using the generate ID function. Uh, so this part is important. So the run.js function allows us to use the JavaScript. We use the window.parent.post message API to essentially communicate between this web application and the Qualtrics that the application is embedded into. What it does is that it sends a message about this task ID and the session ID of the conversation. So here our direction is from the web application to the Qualtrics. And we set up these reactive values to store the conversation. So essentially, these are flexible data structures that would take the conversation log and we record the app launch. And also, we essentially dynamically render the UI. And next is the part that on the back end handles the message sending and receiving. We temporarily save the user input into a data frame as well as the response from the API here into the same data frame. It's called new entry, and then we append essentially this entry into the Google Sheet using the save conversation um, function that we previously defined. And finally, once this is done, we re-enable the send message and hide the load spinner so that the next round of conversation can continue. And then lastly, we want to also update the conversation log by posting the new round of message onto the conversation log display. And we mark the user's message and the system message in a simple way, but of course you can render it with latex. And once this is all done, you can post the web application. Here I'm using republish because it has been published before. So all you need is this web application code and also the JSON file for authentication. I have an account with Shiny app, and then we're just going to, when you hit publish, the application will be updated in this time, but if you do it for the first time, it will be published. And the address is here of the application. And then in the next video, we're going to use this URL and we're going to embed into the Qualtrics. So here is how you hit publish, and it will start updating.